Jai Hind you all, welcome you all in the lecture series of Discrete Structure and Theory of Logic. Subject code is KCS 303. I am Chhaya Yadav. I am here to discuss you the topic of Discrete Structure and Theory of Logic, that is set theory. Now first we have to understand what do you mean by set theory. Basically set theory is invented by George Cotter, and why George Cotter is invented set theory to solve the set of problems. It is applicable in many areas like banking sector, e-commerce sector, applications and in software. So role of set theory is totally involved in every field of computer science. So first we need to understand some basic concept which is involved in the set theory, like what do you mean by set, how the set should be represented, what are the basic types of set, and what kind of operation we performed on a set. So before doing the operation, we need to understand the basic definition of set. Now, what do you mean by set? Basically, set is a collection of distinct objects, or I may say that set is a unordered, well-defined collection of distinct objects. Now, what do you mean by unordered? Unordered means like any number of elements can be represented in a set in any manner. Like if you are seeing on the presentation A equal to 1, 2, 3, 4, 5. So these are the number of elements which is presented in a set. So number of elements can be ordered way and in unordered way, it doesn't matter. It should be 3, 4, 5, 1, it doesn't matter. So it support unordered number of elements should be presented in a set. Second is well defined. Well defined means the number of elements should be represented in a proper way, in a proper manner. Like if I am taking an example, if you are seeing example number 1, A equal to curly braces apple, pear, grapes. So these are the number of elements which is defined in a proper manner, in a well-defined manner. Second, it should be distinct. Distinct means if I am taking a set A and the value of set A 1, 2, 2. So it is not applicable in a set. Why? Because distinct elements, distinct object means that set should be carried only different number of elements. Number of elements can't be repeated, or we cannot use same number of elements in a single set. If I am taking an example, fourth, like A is a set ordered pair 1, 2. Means 1, 2 is a number of elements which is represented a particular set and involved like a ordered pair. Next, we have to understand the members and equality of sets. Now, what do you mean by members? Members is just like the element of a set, or any set which is carried a number of elements is called member. It is the object that make up a set are called members or are element of set. It means if a set A is carry like 1, 2, 3, that is, like 1, 2, 3. So these are the members which is called as member, or we can say that these are number of elements. So we can represent a set A and the number of elements is represented in a curly braces like 1, 2, 3. Now the second point is two sets are equal, they have the same numbers, that is a set is completely determined by its member. Means if we are taking a set A, so it is completely determined by a member, means the number of elements should be presented in a set, so the number of elements should be belongs a particular set. Now comes to the next topic, which is set notation. Now what do you mean by notations? Notation is basically how we represent a set. set basically represented in a capital letters. You may use A, comma, B, comma, C. Any capital letter you may use in a set, or we can represent a set by using the capital letter like S. Okay, and in a set S, the number of elements should be only represented in the curly braces. Only represented in the curly braces means the number of elements also represented in a curly braces. Without curly braces, it should not represent a set. S is a set, and S is a set. Second point is order and repetition do not matter in a set, as I have already told you in the previous sheet. Like order and repetition means same number of elements does not repeat in a set, means we can't repeat same number of elements in a single set. Now the third point is define the following expressions are equivalent, means it is called unordered. It is called unordered. Unordered means we can write the number of elements in the series 1, 3, 9, or we can write 9, 1, 3, but we can't write 1, 1, 3, 3, 9, because non-repeating elements is not allowed in the set. So this is the wrong way. Next is the membership symbol, that is belongs to, and the empty set, which is called phi. Now two concepts may arise in a set, which is first symbol, that is belongs to, and second symbol, that is phi. Now what do you mean by belongs to? Belongs to means for every element of variable x. X is a variable which consists number of elements. Which is belongs, that is called belongs to. Belongs to. It means every element which are present or which are relatable to the x should be presented in a set. S. Okay, so we can read S, x is in S, means the x is an variable, the number of elements, or we can say that x is a member of S, or we can say that x belongs to S. Now I am taking an example, the point number second. An example may be right, S should be right 1, 2, 3, means X is just like a variable which belongs to or which consists the number 1, 2, 3. Means 1 belongs to S, 2 belongs to S, and 3 belongs to S. Now the next point is the negation of belongs to is written as does not belongs to. It means not belongs to. Means if any variable consists and the number of element does not belongs to S, so we may write the notation of belongs to like this. Means any variable, any number, or we can say that number of element is not belongs to S, so we may write X does not belongs to S. Now next point is the empty set. Empty set means is a set without an element. We can say that a set is in empty, means there is no element is presented in a set, or we can represent a set like curly braces, means there is no element, which is called nil. No element is presented in a single set is called empty set. For an object x, x does not belongs to phi. If I am taking an example, x is belongs to variable 1, 2, 3, then it should not belongs to phi. Okay. Now the next topic is defining a set by the membership properties. We have taken an example like set of numbers. We have represent already predefined notation like Z is called set of all integers. Integer means the value start from minus infinity to plus infinity. So we can make a value, we can write the value of integers from minus 2 to plus 2. मतलब the value is arises from minus infinity to plus infinity. So integers value can arise minus infinity to plus infinity. So we may take the set of integers in a set. Second point, z plus is indicate the set of positive integers. It means we have to only take the positive numbers or the positive value in a single set. Means if I am taking the second point where x is a number of elements which belongs to z. Z means set of integers, and the value of x should be greater than 0 and the value of x should be greater than 0 which belongs to z. It means we can start the value of x from 0 which is greater than 0. Means we can start 1, 2, 3 and end up to the positive infinity plus infinity, because the value of integer should be increased up to plus infinity. Next point is z minus. Z minus means set of negative integers. Negative integers means we have to take the negative value of an integers, means we start the value from the negative numbers to the negative infinity. Now next point is considered as r. What do you mean by r? R is indicate as real number. Real number means the numbers should be considered in a positive way, negative way, or in a decimal points. Means we can consider the numbers in a fractions basis. Decimal points means numbers should be considered in a point basis, 0.5, 1.5, minus 1.5, like that. So in real numbers we may consider the positive to negative, plus infinity to negative infinity. But what is the difference between integers and real numbers? In real numbers we have to take the decimal values also. Now what do you mean by q? Q is just like rational numbers. We have to define the numbers in a fractional forms like 4 divided by 5 or 3 divided by 2. So we may consider these kind of numbers in our rational numbers. Next is how we represent a set. So basically we can represent a set in two forms, or we can say that we can represent a set in two ways. First is roster, or we can say that roster is called as tabular form, and second one is set builder. Now what do you mean by roster? Roster means listing all the elements of a set separated by commas and enclosed within braces. Means the number of elements should be presented in a set. We can count the number of elements, means all the elements should be presented in a single set so that we can count and we can see how many number of elements is presented. Like we can simply see and we can say that in set A there are 5 number of elements is presented, which is called first 5 natural numbers. So we have represented these elements in a proper tabular representation. We may not consider any kind of property. That's why the number of elements directly seen on the table is called tabular representation, or we can say that roster representation. If I am taking the example number 2, that is B equal to the set number of elements should be considered 2, 4, 6, 8, means even number of element is considered in a set B. So we knew that already even numbers we have to start from 2 and we end the even numbers up to 50, means we have to take the even numbers from 2 to 50. So we can count the even numbers from 2 to 50. So this is the representation of tabular form, means we can listing the elements, we can count the elements in a set. If I am taking an example C, like C 1, 3, 5, 7, 9 up to the positive odd numbers till the infinity. So we can count or we can assign these kind of numbers in a tabular representation, means we have to mention all the elements like this. So this kind of representation is called tabular. Now second is set builder. What do you mean by set builder? Apart from the tabular, set builder is just representation of a set in a symbolic form. Like we have to represent a set in a form of properties. If I am taking the example number first, which have took in a tabular form like A equal to 1, 2, 3, 4, 5. Now how this set is represented in set builder? We may consider the first 5 natural numbers. So we may take like x is a variable and which is belongs to n natural numbers, means x is a variable and it carry the number of elements which should be supported n natural numbers. So what is the condition? So there is a condition is presented in a set builder form like x is a variable which consists number of elements and the number of elements should be less than equal to 5, means the number of elements is start from 1 because it indicate it is natural number, so it is started from the 1 and it may varies less than equal to 5. Less than equal to 5 means the number should be from 1 to 5, like as you have seen in the tabular form 1, 2, 3, 4, 5. So in tabular form we directly assigning the values in the set, but in set builder form we have to assign a set in the form of property, or we can say that in symbolic form. Now we may take a second example like b equal to x. X is a variable which belongs to or which support number of elements and it belongs to e. E means even numbers, like we have to take even numbers from 2 to up to from start from the 0 and till 50, less than equal to 50, means we have to take a number of elements which is represented in a x, and x belongs to even numbers, means the number start from 2 and end till 50. So as you seen in the tabular form, we have started in example b 2, 4, 6, 8 up to 50. So we may see the direct representation of a set, but in this set builder form we may see the property which may consist like this kind of set. Okay, now we may take same as in the example C, you may calculate and answer the questions. Now the next point is finite and infinite sets. So in a set there is two kind of sets, which is called empty and which is called non-empty. Non-empty means we can consider a set which is nil, or we can say that null set which has no elements inside the set. So it may consider the empty. If I am taking an example, the set may be considered as empty and non-empty. So in non-empty it consists finite and infinite number of set. So we may consider the basic definition of finite and infinite. First we may consider what do you mean by empty. As I have already told you what do you mean by empty, where there is no element in a set which may consist null set is called empty set. Apart from empty set there is non-empty set which may consist various or number of elements in a set. So number of elements in a set can be divided into two parts, finite and infinite. Finite means we may count the values, which is called countable. Okay, infinite is also divided into two parts. We may consider countable and uncountable. So in finite there is a countable, means we have to count or we may count the number of elements should be presented in a set. But in infinite we may count the elements or we may uncount or not count the elements which is presented in a set. As you have seen the definition of finite, a set S is said to be finite if it contains exactly m distinct elements, where m denotes some non-negative integers. It means in finite we may count the exactly number of elements should be presented in a set. Like S is a set and which have m number of elements, so we may count m number of elements. The exact ratio of number of elements should be presented in a set. And if I am talking about the infinite, infinite means we cannot count the value, or we may somehow count the value, which is called, it is not finite. The value is not up to the valid points. It may rise up to the infinity. We may count or we may not count. Now, here is some examples of finite and infinite. First, determine which of the following set are finite. First is, if I am talking about month in the year, so we may count the month in the year. There is 12 months in the year, so we may count the month. So it is called finite because we may count the year. Second is b equal to even integers. We can count the numbers, we can count the even integers, but up to the one limit. From, if I am taking an example, x, the number which contain even numbers from 2 to 50, so we may count. But if I am talking about whole integers, so the values of whole integers from negative to positive infinity, so it is possible to count each and every number, so it may consider infinite. Okay. Now, example C, equal to positive integer less than 1. So it may consider finite because we have analyzed, we all are very know what do you mean by integer and what is the value should be less than 1. It all create all negative values like 0, -1, -2 up to the minus infinity. So it may be finite, means we can count the number of values which is presented in set C. Okay, we have take the example D, animals living on the earth. We can count the animals which is living on the earth. We can easily count how many animals which is living on the earth. If lines parallel to x minus a axis, so it is infinite. We don't know about the proper how many lines are parallel to the x axis and what number has to be the lines should be there from x axis. Now, next, but not the least topic subset, which is most important topic in a set, we have to consider what do you mean by subset. So basically, subset is create a relationship between two sets which is called set A and set B, and what may if consider A is a subset of B, like all the elements of A is presented in set, all the elements of B in set B, means all the elements of set A is presented in set B is called that A is a subset of B. But if all the elements of A should be presented in B, then what should B called? B is a superset of A. Means if I am taking an example, A is a set which may consist the values -2, 0, 6. So -2, 0, 6 should be presented in set B. So here we check -2, 0 and 6. So all the elements of set A which is presented in set B. So we may consider A is a subset of B. Okay, and B is a superset of A. Now, if I am consider A is not a subset of B is called negation, means no elements of A should be presented in set B. So we may consider X is not belongs to B and X is belongs to A. We may consider X is not a subset, A is not a subset of B. Now, next topic is proper subsets. Proper subset means if I am again taking an example between two sets, set A and set B. So, how we can say that A is a proper subset of B? Means the proper subset notation is this, like this. We have to represent the sign of proper subset like this. Okay, so we may consider A is a proper subset of B. When A is a proper subset of B, when A is a proper subset of B or B is a proper subset of superset of A, if and only if A is a subset of B and A is not equal to B. Means if I am taking an example like set A consider 1, 2, 3 and B is consider 1, 2, 3, 4, 5. First condition is follows that all the elements of A should be presented in all the elements of B. and A is not equal to B means the number of element is 3 and the number of element is 5. It means 3 is not equal to 5. A is not equal to 5. The first condition is what? First condition is when number of elements of A should be presented in set B. Second condition is when A is not equal to B. So 3 is not equal to B. It means A is a proper subset of B. So this is the ratio where positive integer is a proper subset of integers, is a proper subset of Q, and rational number which is considered as Q is considered as a rational numbers and is a proper subset of R, that is real numbers. Now next condition is if as is like a set is not equal to phi, then obviously phi is a proper subset of S and it is property which is satisfied. Now the next topic is power set. What do you mean by power set? Power set is the set of all subsets of a set is called the power set. It means if I am taking an example, I am explaining through the example, like any set A equal to consist 1, 2, 3, then what should be the power set of A? So if the number of elements in A equal to n number of elements it may consider, A equal to n number of elements it may consider, then the power set of any set A consider 2 raised to the power n. It means we may consume, if I am taking an example, A equal to 1, 2, 3, then the power set, the number of elements equal to 3. Then the power set of A should be 2 raised to the power 3 means 8 number of elements should be 8 number of subset, sorry, not element, 8 number of subset should be considered in a power set. If I am taking an example like power set of 1, 2. Third property is always use power set of A equal to what should be the 8 number of element? First element always phi. Phi should be considered as an first element of power set of A. Now second is a subset 1. We may consider the subset 1, then subset 2, then subset 3. Then we have to make the 8 possible combination. 1 subset 2, 3, then subset 1, 2, then subset 1, 3, then subset 2, 3, then subset 1, 2, 3. So these are 8 number of elements should be considered in a power set. Okay, next is P of S. If I am taking an example, it should be 1, 2 is a subset, then what should be the subset of power set of this set? So here are this is 1 and here are the 2 raised to the power 2, that is 4 possible combinations should be represented. Now next topic is Venn diagram. So why we use Venn diagram? First we have to use Venn diagram for visualization relationship of some set. If I am taking an example, like if set A is somehow relatable with set B, so we may consider or we may give the representation through Venn diagram. So basically Venn diagram is used to visualize relationship of some set. Second point is that each subset of U, the rectangle U means that is universal set. Universal set is the set where all the elements should be represented and it is denoted as in rectangle form. Means universal set should be represented in a rectangle form, which may consider universal set. And what do you mean by universal set? Universal set is just like a collection of all the elements in a set is called universal set. Now we have represent some sets like set A and set B. So we may consider the relationship between set A and set B. So we may use the Venn diagram. So this is the representation of Venn diagram which include the rectangle and circles inside the rectangle, inside the universal set. Why inside? Because universal set carry all the elements. So if I am considering set A and set B, so set B and set A also consider inside the universal set, because A and B is also the part of universal set. Now there are maybe 4 and 5 operations which may consider in a set operation, which is the most important topic of set operations. We have to calculate so many questions regarding set operations. Now the first operation, let I am considering the two sets always A comma B, subset of some universal set. As I have already told you in the previous sheet, in the previous what A and B are two sets which are relatable each other, and we represent the operation through Venn diagram and by using the help of universal set. There are following set operations create new sets like from A and B. The first operation is that union. What do you mean by union? Basically, union is when assigning the relationship between A and B, and it is a representation of U. U is just like the representation of union. Now what we have considered in the union operation, if I am taking an example of union, like set A is considered 1, 2, 3 and set B is considered 1, 2, 4, 5. So all the elements which is represented in set A and set B without repeating the elements. How many elements should be represented in both the sets? Distinctly, means all the different objects should be present in both the set we may take in the union operation, like 1, 2, 3 and 4 and 5. 5 number of elements is distinct which is presented in set A and set B. So the union operation should be 1, 2, 3, 4 and 5. So this is the representation and calculation of A union B. Now how we calculate the union operation in Venn diagram? We may take a set A which may consider 1, 2, 3 and set B which may consider also 1, 2, 4, 5. So 1, 2 is a common which we may not take the common elements. We may take all the elements, like we may take all the elements which is considered in both A and B but not repeating the elements. It should be distinct. If 1, 2 is repeating, so we may consider only one time 1, 2. We may not consider on repeating elements. Second operation is intersection. In intersection, the representation sign is opposition of U. It is the opposition of U. We may take only the common elements which may considered in set A and set B. Means if I am taking an example, set A 1, 2, 3 in set A and set B 1, 2, 4, 5. So the common elements should arise is 1, 2 and 1, 2. So the intersection operation is defined to create or to analyze the common element should be presented in both the set A and set B. We may consider this kind of operation in Venn diagram also. This is a universal set, this is set A and this is set B. So set A consider 1, 2, 3, 1, 2, 3 and B consider 1, 2, 4, 5, 1, 2, 4, 5. So 1, 2 is a number of element which may consist in A and also presented in B. So we have to take only the common element which is called A intersection B. Clear? Now the third operation is set difference. Set difference is just like minus the values from set A and set B. If I am taking the set A which means minus set B, A minus B. What it mean? It means A minus B. It means all the elements are presented only in A but not presented in B. Means 1, 2 is a number of element which is also presented in B. So we may not consider 1, 2. All the elements which only be present in set A. So 3 is the element is presented in A only, not in B. So A minus B is 3. If I am taking another example like 2, 4 and 5 minus 2, 4, 6 and 7. So 5 is the number of element, 5 is a single element which is present in A only, not in B. So we have to only consider the element should be presented in A only. Means we have to analyze A minus B equal to 5. Okay, and if I am talking about B minus A, so all the elements is presented in B only, not in A, and not consider the common elements. Means 1 and 2 is not considered. We have to take 4 and 5 which is presented in B only. Same as this calculation is represented in Venn diagram. It is set A and set B. This is a universal set, and A set consider 1, 2, 3, B is consider 1, 2, 4, 5. So only consider in difference operation what we consider the A minus B. If I am considering A minus B, so we have to consider the number of element presented in A only, not in B and not the common element. So 3 is the element which is presented A only, that is A minus B. Next operation is set complement. Set complement, like if A is a set, if it is considered 1, 2, 3 and U is a universal set. So what should be the A complement? The complement sign is A apostrophe S dash or A apostrophe C and A bar. So this is the sign, this is a representation of A complement. And how do we calculate the A complement? We calculate the A complement like all the elements are presented in A. We not consider the elements presented in A. So except A, except set A, all elements in universal set is A complement. Means all the elements should be presented in A except A set A is considered as A complement. So these are some basic identities which may consider the set operations and may use in the okay class. So for today this is over now. We will consider next topic in further next class. Thank you so much.